Login accepted.
Good morning, everybody. This is an amazing room, right? Every time I'm in this room, I'm like, oh wow, this is so big. And I was actually preparing for this talk to be in a small room because, well, it's 2024, and who would be interested in still in microservices, right? We've done all that, we've been there, we've seen it all, it failed, we couldn't make it work, so we started doing other stuff, etc., etc. And yet, we're still in this big room talking about microservices. A bit to my surprise, actually, to be honest. So, first of all, let me tell you, I'm really excited to be back in Krakow. I visit Krakow about once, twice every year. And every time I come here, I enjoy it even more. I'm like, this is probably the best city east of Amsterdam, right? So, actually, there's... I'm not sure what else is east of Amsterdam. Anyway, it's also probably the best city west of Amsterdam. No, I'm not sure. Actually, there's more and more vintage stores every day. I found this really nice shirt yesterday in a vintage store. Isn't it cool? So I decided to wear it. Yeah. So let's talk about microservices then, right? So what is there to talk about microservices? Well, lots of things, actually. People write all sorts of stuff about microservices. And the thing is, are they true? Yes, maybe they are. And I've seen quite a lot of companies fail at doing microservices, quite often because they were doing them for the wrong reasons, I think. Let's see a bit what the media say, right? So there's this was in the news a couple of months ago. Is Amazon Prime Video team throws AWS serverless under a bus. As a result, everybody started panicking, right? So, oh wait, Amazon is throwing their own serverless technology under a bus. That means nobody should do this. No, there's a small team somewhere in Amazon that says, hey, we're going to do something different. That doesn't mean that you have to be scared of microservices from that point on. And then people say, yes, microservices are dead. They never work. Let's go back to a monolith. It's not necessarily the wrong decision, by the way. It's also not necessarily the right decision. There is no right and wrong in this case. Or people say, yeah, the death of microservices. Then nobody knows what we're going to do after that, of course, but that's the thing, right? And are microservices really dead? Well, they're not, basically, but it's all, don't listen to all these opinions about everything, right? AI is not going to, I have to say something about AI, right? Every talk has to say something about AI. It's not going to take our jobs. As yet, right? It will do in 10 years maybe, but not now. And the thing is, it won't because we solve the problems as human, right? Humans solve the problems. For now, AI helps us to do that, actually. So that's enough about AI for today, right? So what is it, microservices? Well, this is really nice and really short definition of microservices from Martin Fowler. It's actually quite complete. And it basically illustrates, I'm not going to read it all to you because it's way too long, it basically illustrates the complexity of microservices because it's not something you can put out of a box and apply Spring Boot, done, right? No, there's a lot of thought that goes in there, right? And actually I was in one of the first microservices project, at least in the Netherlands, maybe, I don't know, that was in 2014, and I convinced the CEO of this insurance company that for that problem, it was good to do microservices. And then he listened to me for 20 minutes, and then he said, yeah, sounds good. And I was like, oh shit, now I have to think about what it really means. There was no definition at the point in time. There was no technology, so we have to figure it out all on our own. And we did over time, right? And as I said, I think it's the complexity of the whole subject that sort of scares people away, and it should, by the way, because a lot of new complexity comes in. And I'm going to try to illustrate to you what it did for us, and also why we started applying this technology, or this set of techniques, basically, because there is no technology that you can just pull out of a box and you're there. So the problem that it helped me to solve, and you would probably say, oh, scalability, right? Probably most of you went into microservices because scalability. And the real thing about scalability is not a lot of people actually have scalability issues. So I'll give you some examples during this talk about companies that thought they had scalability issues, but really don't. And the problem that we try to solve mostly with it is this. It's called technical debt. Now, by a show of hands, who of you does not have technical debt? See? You are the lucky ones, right? So either you don't write code or you're just lucky. Or you have it very well organized. That's good. The rest of us are all here, right? So the question is, what is technical debt? Now, Ward Cunningham, the inventor of the wiki, he said this. He said, well, shipping first-time code is like going into debt. A little debt speeds development, right? You take some shortcuts just to be quicker, to meet the deadlines, to meet the CEO saying, how hard can this be? And you're like, yeah, but it's really hard. And then they say, well, hurry up, because there's a deadline, and we need to have these features implemented by then and then and then. And you're like, oh, and so you take some shortcuts. That's what we all do. And these shortcuts are okay as long as we pay back that debt that you taking these shortcuts by doing some refactoring. And then you get to the next point, is that a lot of managers, product owners, whoever, right, say like, yeah, but we don't have time for that, because we need to add even more features with strict deadlines and stuff like that. So if you try to plan for doing refactoring, you usually, well, you get 0 on your plate, right? It's like, we're not going to take time for that, we're going to do this stuff. And the thing is, you need to do refactoring anyway, because it's part of our job, right? It's always part of our job. You just shouldn't tell anybody that you're doing it, because they will think, what's the point in this? Well, the point in this is solving that technical debt. Now, it gets worse, because what Ward Cunningham also says, he says, entire engineering organizations can be brought to a standstill under the debt of an unfactored implementation, whatever your paradigm, right? Whether you're good at functional programming, imperative, OO, whatever the paradigm is, we all suffer from technical debt, right? As you see, this really big room, and only like 5 people did not have technical debt. We all have it. The problem is you can come to a standstill. I'll give you some examples of that. So this is the office building of an insurance company. This is the insurance company I was talking about. And they had interesting things to solve, right? They had a mainframe on-premise. That mainframe alone, keeping it running, cost €1 million. I'm not sure what that is in zloty, but probably times 4, something like that, right? So 4 million zloty to just keep it running per year, right? That's a lot of money that goes in there. It got worse because the code running on that mainframe was written in 2 languages, one of which was this one. Well, there's a lot of issues with this thing, right? Do you know what this is? COBOL, yes. The best language there is, right? Because still, most of the code that is running in production in the world is written in COBOL, right? So you can make a ton of money becoming a COBOL programmer because nobody wants to do it, basically. Because they have all these like if statements and stupid stuff and old-fashioned stuff, right? And you're like, what? Old-fashioned stuff? No, different topic. Anyway, so the problem with this code is that it's in COBOL, so not a lot of people understand it even though it's quite simple. It's also in Dutch. That doesn't really help, actually, right? And then, because of the limited space in the registers, they had to abbreviate or make acronyms out of all the variables, so like it's ing.oc. Nobody knows what that is anymore these days, right? And the problem they had is that the people who wrote that code, so this code has been running for like 30 years, something like, they aged, right? So at some point, they wanted to retire. And they couldn't, because they needed to keep this code running. That's an interesting challenge, right? They built up so much tech debt, basically, that they couldn't get rid of it. They spent 12 years in 6 attempts doing big projects, 2-year projects, and failed miserably. And then we started doing microservices, and it solved all their problems. It didn't, by the way, but it sounds nice. So here's my current client. I'm the CTO of this a nice e-commerce company called iBOOD. Yes, we have a shop in Poland as well. These are the CEO and the CMO. And they said, well, we want to be in your slide decks. So I took a picture of them and I put them in my slide deck. Has no meaning other than that, but they really like that. So here's the problem. iBOOD started as a small company having a single deal on a web page, and they had an Excel spreadsheet to manage it. All nice and fine 20 years ago. And then they started growing. So they built up their website, and then when their website wasn't good enough anymore, they built a new one. The project was called Next, as all these projects are called, right? If you don't have a project called Next, well, where do you go, right? So what do you do? And then they had this growing number of legacy systems, right? They had an ERP system written in Python. They had a CMS written in PHP. They had an old CMS, which by now is the old CMS, also written in PHP. They had a data warehouse, some stuff in Java around DB. They had an Oracle system for doing all sorts of these systems. And then at some point, they started doing microservices. They had really weird names when I got there. Like there was a microservice called Panda. I could not make up what I was doing, right? But it was doing something. It was written in Python. We couldn't figure it out, and it grew and grew. And then they put it on all the clouds they could think of, right? They run on GCP, but they made backups on Azure. Okay, and these backups, we couldn't find them for like 2 years, actually, after the person who wrote them went away. And then we have to connect with all sorts of external parties, like payment providers, marketing tools, analytic tools, whatever you can think of. And as a result, over the years, because this is like a picture that displays like 15 years, they started copying around the data, because at some point, they needed to do accounts. Right? We have a lot of customers, and at that point in time, they had a PHP developer, so they put it in the CMS. So there were 2.3 million customer accounts in our CMS system, which is probably not the best place to put them, right? Especially if you're an e-commerce company. And then, because they had the data everywhere, it needs to be kept in sync, which made the problem even bigger. So we use the ESB, we use CSVs, we use Excel spreadsheets, they ship them around in emails, and exporting them from one system, putting them in the next system every day, right? This is doomed to fail, basically, and it, well, sort of did. The problem with technical debt is basically this. This is what Ward Cunningham was talking about. The more and more time you need to keep your systems running, the less time you have to move away from it. And moving away from it is quite often very necessary, because you want to be able to do new stuff, right? If you're an e-commerce company, you want to be able to change your website, change the design, do whatever. They could not. They hadn't released their mobile app in 2.5 years. 2.5 years, right? That's a very, very long time. Or the insurance company, they wanted to have new policies or new laws being had to implement. They just couldn't. They had to move away from this. This is really troublesome. And in the end, and this is a slide I'm going to show you a bunch of times, dependencies will kill you. That's basically it, right? Everywhere, all the dependencies, no matter how small, they will kill you in the end. And that's a problem. So the question is, what do you do now? Well, this is a good time to introduce myself. I'm going to do that really, really briefly, actually. So this is me. I'm an independent dad. I have 3 kids. All 3 of them have been here, by the way. I speak a bit, I write a bit, I travel, because I like traveling. I'm currently the CTO for this company called iBOOD. And mostly, I'm a lifelong programmer. I write code every day. I haven't written any code yet today, but I will do in the afternoon for sure. I do it also on the weekends. I just can't not write code. There's always code running in the back of my head. Do you have that too? It's weird. It's like an addiction, right? There's always some code. I'm actually thinking about writing the taxonomy service again today, and that's running in the back of my head. By the end of this talk, I will be able to type it out probably, right? To prove to you that I'm a programmer, this is me. I am actually double object-oriented. It's my parents' fault, right? It gets worse because I live in Amsterdam and I live in the Javastraat. What can you do, right? This is the view from my window. So I also publish a bit in open source. This is our TypeScript framework for writing microservices. Feel free to star it, because we don't have too many stars yet. So what I'm going to tell you is that stuff that works for our context, right? That doesn't necessarily mean it works for you. It might take away from this whatever you want, right? So, but I'm going to broaden the scope a little bit. It's not just about microservices, because, well, the dependencies will still kill you if you think about extracting services from your existing landscape. And that is an issue. And I want to be able to talk about that issue a little bit today. So, one more short example. This is another company I work for. This was their tech stack. I asked them, so what do you do? And we put it in a Confluence page, and these are all the things that they were using at that point in time. They had 30 people on board. They went bankrupt, basically. They went overboard. They lost it to technical debt. They just couldn't update their stack anymore. They were doomed, right? And this is what we tend to do, right, as developers. This is basically what we do every day. Any one of us, including me, it's like, every time I'm like, oh yeah, this sounds like good. This is probably going to be easy. It never is, right? Because it's always all this other stuff that you need to take into account. And we always are, we're optimists, by the way. We always are too optimistic about what we do, and we tend to get lost along the way. That's just how life works, right? And that's probably the only thing that we are able to, the people can blame us for, is we always think it will be okay, and it's never, right? It's always more complicated than it is. As a result, we need to take small steps. Now, to prove that, there's a thing called Gall's law. And John Gall says, a complex system designed from scratch never works, right? So building the next big system is going to fail. If you're in a project like that, quit. Or find something else to do, but that's basically it. It never works. It has proven never to work. So if you want to start over, if you want to move in towards a newer technology style as is microservices, you need to do something different. And what it is that different is, well, it depends on the situation, but most of the situations that I've seen since I started doing microservices require us to do this. The thing is, you can never just shut down everything and say, I'll come back in like 4 months and we'll have a brand new architecture for you. It doesn't work. So you need to step by step move away from where you are. And the thing is, that requires some sort of what I call continuous renovation. It's a nice finding the right balance between innovating away from where you are and keeping the rest running. Because you can never stop caring for the older systems, right? So this, by the way, is my bicycle repairman in Amsterdam. Really nice guy. If I have something on my bike, I usually spend half a day listening to his old stories. It's really nice. It's like craftsmanship, right? That's what it's about. So anyway, so the thing is, we decided to do this at iBOOD. We said, well, we need to move away from being stuck. And we're going to spend 70% of our time on innovating away. We're going to spend 20% of our time still adding small features to the existing system. It's to keep the users happy or meet new laws and whatever we do, right? Small stuff, and we keep the lights on just solving the bugs. But we need to innovate away from this. And this nice little gentleman here says, invent and experiment. And Jeff Bezos says, to invent, you have to experiment, right? To innovate away from where you are, you need to allow yourself to move into different directions. Into directions you not necessarily know where it will end. Like in 2014, when we said, we're going to do microservices, nobody knew how to do that, right? It took years to get it right, actually. So you need to experiment. The problem is a lot of large organizations, if you're working for a large organization, figure out whether they are actually willing to take the experiment, whether they are willing to have it fail as well, because that is basically what an experiment does, right? So it's a test in order to learn something or to discover if something works or is true. So it could also be false. It could also not work. And you have to allow yourself to do that, right? And that requires courage, basically. That's why courage is one of the elements of extreme programming, right? So the thing is, if you don't make any decisions, if you're stuck, you will get stuck more because time lapses, right? And it passes by before you know it, and the problems only get bigger and bigger and bigger, and you basically die. You fade out. So you need to move away from these small steps, of using small steps. And there's a really simple illustration that will prove to you that this is the thing, right? The smaller the steps you take, the more feasible they are, the better you can take those steps. And that's what we did. We figured out, we went into 4 different directions. I'm going to talk about 3 of them a little bit. So we started delivering features. We stopped doing projects because projects have elements in there that are way too big and they get in the way of doing other stuff. So you have to break it down into smaller things that you can actually act on. And we do that in shorter cycles, right? We just throw everything overboard that we learned from Agile. We went beyond that, basically. And we do it with different teams. I'm not going to touch teams today, well, a little bit, but that's about it. And, of course, in smaller components, meaning you can build your software in smaller components. And whether that's a modular monolith or whether that is microservices or microarchitectures, that's up to you, right? So here's the thing. Smaller features. The question is, how do you find these smaller features? And we resulted in looking into the literature over the last 15 years and figuring out some ways of doing it. I'm going to talk you through that, actually. So here's the thing. First of all, we started to apply event storming. Now, this is an interesting picture, and Alberto, I'm not sure, Alberto's probably not in the room, but who invented event storming, and it uses colored post-its, basically, and it's a technique to identify your processes and identify the actors on it, and slowly find out the domains within your business domain. And we didn't have colored post-its, so we used all yellow ones, which is very confusing, by the way. And I showed him the picture this morning because he's here, and it was really funny. So event storming usually works like this. This is a nice event brainstorming graph. It's not one of ours, but we still don't have colored post-its and used it already. So it looks a bit like this, right? You can find the events that take place, and you can find the commands that leads to these events. And sometimes, if you're lucky, the aggregates will actually sort of appear in your model. And the aggregates are the ones you're looking for, actually. And I'm going to show you why that is in a sec using, of course, domain-driven design. So again, this is like, if you don't have the colors, it looks like this. It's horrible. It actually works quite nicely. The people on this picture are the people from the business at iBOOD. And they had never done this before. We spent an afternoon doing this, and they got a lot of clarity from this particular business process, which is basically the buying process we have. By the way, it goes around the corner, because there were more windows there, and we put stuff on the windows as well. So there's lots of stuff, and we're now sort of like automating parts of this, actually. So the thing is, if you look into history, there's a lot of good practices out there, right? And they all point in the same direction. So let me show you a little bit. So this is the first one, right? We're talking about high cohesion and low coupling. This is a very old principle dating back from the 70s. And it basically means the stuff that is in one module, component, whatever you call it, service, should be highly aligned and highly cohesive. Right? That means if there's a change in the code of one of the elements in there, that has probably effect on the other ones as well. Whereas stuff that is not in that particular component, that sits in another component, should be as loosely coupled from the other components as possible. This is a sense of direction, right? It means putting stuff together. And it doesn't mean, like in a monolithic application where we have a layer of all our repositories and a layer of all our entities and a layer of all our gateways. No, it means you put the stuff together that belongs together because it's about the same topic. Let's call it topic for now, right? So this is a very good point of direction. Also, if you look into the Unix philosophy, also written down in the 70s, this has the same direction, right? It says, well, write programs that do one thing and do that one thing really, really well. And then if you look into the solid principles, which you're probably all very much aware of, there's this thing called the single responsibility principle in there, right? The single responsibility principle points to exactly the same thing. It says every module should have the responsibility of a single part of the functionality. That particular part you still need to identify, but and that is what you do. And that responsibility is entirely encapsulated in your module, component, service, function, whatever you might have, right? And that's the thing. It's always in towards the same direction. And if you look into code bases, and you see this is one of our Python code bases, and I end up in a file with 353 lines. I'm already getting this, it's intuitive, right? It's like 353, there's probably doing a lot of things that do not belong together, right? So having a simple architecture helps. Thinking about what code does is a very important thing. It's the same here, and this is TypeScript from our more recent, from our current team actually. And somebody was writing this particular repo, and it had 5 gateways in there, meaning it pointed out into 5 directions, including the ESB, including some databases, including some other services, etc., etc. And I'm like, it doesn't feel right. It's not really big, but it still doesn't feel right. Why would you need to have 5 repositories to put it together? Well, you need to put stuff together somewhere, but it had different responsibilities. As a result, the code looked like this, right? This is, again, TypeScript, because we do TypeScript. And I'll explain to you why in a sec. But so it does a lot of things, and I was like, it doesn't feel right to have to do this. Why do I enrich a profile in the same function as where I enrich claim products, whatever they may be, right? It doesn't feel right that these things should belong together, right? They're different things. So pull it apart. So that whole idea is there. Now, if you look into domain-driven design, you have probably all read the Blue Book, right? Or at least you can use the Blue Book to put it under your monitor so your monitor sticks out from your laptop, right? That's what most people use it for. It's a very interesting book. It's one of the seminal books in this industry. It's a bit hard to read, though. So I'll explain it to you in about 5 minutes, and that's a good starting point. So there's this interesting pattern in there, and I didn't get this particular pattern until I had to investigate microservices. I read the book when it came out in 2004, 5, 6, somewhere there, and I didn't get this part of the book at that point in time, because I was used to having this single model representing everything I could do in my single application. We were building monoliths right at that point in time. We started moving towards much smaller stuff later on. And then it occurred to me that, wait, there's this bounded context thing in there. So what he says, basically, if you have this big model of everything that you can do in your organization, or even whatever you're building in your product, and you put it in a single module, it gets more complicated every day, right? If something changes there, it might have an effect on something right there, which you don't want. You want to be able to break it up. So what are the guidelines to do in that? Well, I'll show you a bit. And it has to do with something called the ubiquitous language. It's a really hard word to pronounce, but I got good at it over time, the ubiquitous language. It basically means that everything within a particular area has only one meaning. And this is typical for this model, right? This is a simplified e-commerce model. By the way, e-commerce is way more complicated than this. And there's this product thing in the middle. Now, the product plays a role on the right side of this diagram about replenishment, and you get new stock when the stock is out, and that's a part of the responsibilities of product. It's also part of when you sell something, so it's on the order, right? An order has order items, has products, etc., etc. And yes, you can put it in the same model. If you're used to doing relational data modeling, you probably do this. However, the thing has two different meanings. And if you pull apart those two different meanings, that's a first nice guideline for separating out parts of your software into smaller and smaller components. You're still not at microservices level, by the way. You're still one level up, I think. That only realized later. So that means that this is the loosely coupled situation that you want, right? It's better than having this single model because everything is dependent, everything is tied together. That's why we still have all these dependencies. So then there's the next level, and it's called the aggregate pattern. Now, Eric Evans says, an aggregate is a group of associated objects which are considered as a single unit with regard to data changes. And he's like, oh, transactions. Yes, not everybody has transactions. We don't use relational databases anymore, but it takes away the leverage of having transactions. But the pattern is still there, and it's really good. And basically, if something changes together, that's when you want it together. It's pretty similar to looking at high cohesion, low coupling, single responsibility, Unix philosophy. They all point towards this direction, right? And the question is, well, how do you find them? Well, you find them by taking the bounded context and looking into the data changes, right? Now, here's the next pattern. Every aggregate has a root. That root is an entity. Entity is also a pattern from DDD, which I'm not going to talk about today, but it's the elements that make up your domain, right? So every one of these aggregates actually has an aggregate root. To give you one example, basically our order service, we have an order service, that's what e-commerce companies do, right? And the order is the root element in there. It's an entity, it has, an order has order items, order items have offer items have products, there are the prices that are in there. An order also has your profile in it, your payment details, etc., 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 except for, of course, your credit card numbers and stuff like that, but that there is a payment is there. So the payment is also there. So it's the whole aggregate. And the nice thing is, we build up that aggregate in the basket, and when you have paid, we actually save the whole thing at once into the service, and the service is responsible for handling that. That is particularly what an aggregate is, and the order class is the root of that. So as a result, you come to this particular thing. You figure out the bounded context in your domain. You split up the domain into doing that. And within those bounded contexts, we usually find the aggregates. By the way, this is a very, let's say, organic situation. They change over time. So the services that we found over time while doing this, taking small steps, they still evolve, right? And we're like, oh, sometimes we say, oh, but this should actually not be part of that particular component. We'll pull it out, right? Or I'm now rewriting the taxonomy service actually as we speak. That was the code I showed coincidentally when I started the talk. It's stuff like that. It's very organic. It's not static, right? Once you found this breakup, it can change over time because you find different meanings of the language used in your domain over time. It just happens. And this is the thing. It works really nice. And that is basically the level you can build microservices. This is the right level. It's not the bounded context level. Bounded contexts are too big for microservices because the thing is they want to be independently deployable, etc., running on their own processes, being able to scale them up if necessary, and that does not work for bounded contexts. It does work for aggregates, though. So we can squeeze up, or we can scale up these single services whenever we need to, usually when there's a big sale, which we have every quarter. And the mapping is quite extraordinary between DDD and microservices. To show you that, so it's like microservices are responsible for their aggregate. We do that by naming the service, actually. So we have, well, we don't actually have country, by the way, but iBOOD.com/, it depends where we are. That's the name of the service. It's the resources it's responsible for, which means it delivers responsibility on those resources. So if we want to get a list of countries, we would go to this URL and figure it out, right? And the thing with the aggregate root is the entry towards your aggregate. That means if you identify a single one of them, that is exactly where you want to be. So if I wanted to be able to get to country 38, I get everything in there, right? If I want to get one of my orders out, I have the idea, which is a URI, by the way, and I get the whole order thing for that particular order. It's the address where that order lives. It's also where you save that order again if you make changes to it, right? And there's usually other ways of getting that. For instance, in countries, I can do sorts of queries. I can do queries on lots of stuff, right? For instance, if I want to get the deals in a particular vertical, in a particular country, in a particular shop, it usually ends up like this. So there's a really nice and tight mapping between those. And that is really good. So what's the next step? Well, the problem is, what a lot of people do is they build this. They build the single application which sits on top of a bunch of services. People are able to pull out these services at some point in time, and they still have these big applications on top. The problem with this model is, well, you still have all these dependencies, right? Because in that particular application, I'll pull it back, in that particular application, everything is still connected to each other, right? And what we decided to do over time, and this is like the 5th iteration I'm doing with the company here, is we decided to split that up too. So what we realized that if we are building up business processes, which we do, like an e-commerce business process where you select a product, you select another one, you put it in your basket, or your cart, or whatever you call it, and then you go to checkout, right? And in checkout, you need to get yourself registered as a customer if you're a first-time customer, register your payment, and then you go back to showing the order, and that's basically a very simple version of the process. If you put all that in a single application, it is still dependent on everything. You still didn't break through the dependencies. So what we decided to do is change this a bit. We decided to say, well, what if we do the same thing to our application as we do to our services? And we started breaking them up. And also, they have their own domain, right? They have their own part of the domain model. They have their own aggregate, which is very different from any one of these services. So it's very unlikely that an application, or an app as we call it, has the same domain exactly as one of these services. They usually mix and match from different services, or go to marketing tools, go to the data warehouse, whatever, right? It sort of builds up. So we have an app for products, we have an app for our basket, we have an app for accounts, for our orders. We literally have those. If you would go to the iBOOD website, and you would, please do that, and and then select a product, you're in the offers app, as what we call it. You don't see that because that's the root, actually. But if you go to checkout, you will see that in the URL, there's this phrase called basket. Basket is a different app. They look the same, but it's a different app. And if you go further than that, you go into, if you actually have ordered, you go into the orders app, which allows you to show your order. That's based around that part of the domain. That means we currently have about 20 of these small applications sort of working together, but are very loosely coupled. That means we can actually deploy each of those to production whenever we want. And we do this all the time. We do about 40, 50 times per day. One of my colleagues says we do it about 80 times per day. I have a hard time believing that, but it's a large number of times. So the next dependency that you need to kill is the data. The database is also a really big and interesting thing, right? It also has the same dependencies. So if you keep the database intact while moving to services and even microapps, you still have all of those dependencies. So this is what people usually start with, right? You have a monolithical database, fine, and a monolithical application. They belong really tightly together. That also makes it really hard to move away from it. And then people started building components or services or whatever you want to call it, and they still stick to the same database. And it's the same problem you have with the apps, is that, well, there's still all these dependencies in there between all these tables in your database, and they can still kill you, because if you change something there might break, and then all your components fall apart, all your apps fall apart, so you're still not there. So you need to move slowly, step by step, into a situation that looks much more like this. However, because you can only take small steps and you need to keep everything running, you need to figure out a technique or a technology that helps you get there. I was actually meaning to create a new slide this morning. I didn't find the time for it yet. But so what we did is we used a tool called Devoxx, and Devoxx looks at the changes in the databases. So every change, it looks to the logs of the databases, and every change that is made there, it signals one of our workers. And these workers say, oh, there's a change on this particular offer, on this deal, on this vertical, whatever we have in the old systems. And it reads the data from the database using humongous SQL statements. It shapes it in the way that our services like it and then drops it into the servers, which means every change in the old systems is actually also propagated into the new services. It's a pattern that I can recommend. It's complicated, it's not fail-safe, but it's the best we could find over the years. And you end up with different databases, different stores, or different collections if you have a document database for each one of your services too. And the nice thing is, if you do that, you can move to a situation where different services use different storage technologies, right? Most of our stuff goes into a Mongo database, some stuff goes into relational databases, some stuff talks to the API of some existing external system, and some stuff just happens to be a JSON object. So our full taxonomy, it's the one I'm working on now, our full taxonomy is in a JSON file in the taxonomy service. Because it never changes, basically, it's fixed. It's the Google taxonomy we use, so that's it. So we don't do much else than just get data from it, that's it, right? That's all we do. So it doesn't have to be in a database. It's kind of weird, right, having that stuff not in a database, but that's how it works. And we started moving to document databases as well. And there's a good reason for that, is that, so we do Mongo. So I'm not working for Mongo, by the way, but I really like it, actually, because what it has collections. It doesn't have tables. A collection has documents. Let me put up all these things that are in here, right? Is there one more? There's one more. So we have, for every one of our tenants, we have a database. For every one of our services within that tenant, we have a collection. And a collection contains documents. Documents are JSON, basically. So I can push a JSON object into the database. They don't even have to be the same shape. For instance, we have a contents collection that has about 20 different shapes of data in the same collection. It doesn't matter. Mongo does not care about that. The good thing about this is that the aggregate in your service, you can just get the JSON from there, push it to the database in one single statement and in single update. So there are no transactions in here anymore. So that's how we roll, by the way. So let's go to the next part. We do this in smaller components. And in smaller components, basically services, right? The thing that we decided to figure out is that how can we get this running? We have a fairly small team, where we're 13 people currently, and we have over 125 different repos. That means we all own all of our code. There is no code ownership. Yeah, the whole team does that, actually. And we also figured out that it would help to have an architecture that is quite simple to maintain, and also is very adaptive to what we do. It basically means we need to be able to open up any of our code bases, recognize the architecture and the patterns and the layers in there and the types of classes that are in there, and see, okay, that's where I need to make my change. Because we have, if you would average it out, it's about 10 repos per person, right? And one of those persons being me, and if I'm on a stage, I cannot write code. So 12 and a half, basically, probably. So I wrote this book in 2004, I think. And it contains this architectural picture, which I'm going to show you quickly. It's basically this. And I'm not saying use this particular architecture, but use something like this if you are going into microservices, because having the same architecture, even in different languages, would help you to recognize the code bases easily, right? So there's the domain. In the domain, there's the entities and the value objects and the enumerations. It's the center of what you do, right? This is typically domain-driven design. Around that, still in the domain layer, we have the repositories. Repositories are classes that help you get instances of your entities, usually by the aggregate route. So there's an aggregate in each of one of our services and apps. Around it, we have, the light blue doesn't really show very well. It is light blue. We have a process layer. That's where use cases live. And you're like, use cases? Yeah. We have some process logic every now and then that we put into a use case. It kind of makes sense. We also use them for authorization. We also use them to recognize the pages in our websites. They are also named after the use cases. And then there's the top layer, which is, if it's a service, it's the resource. It's where you come in. So we have a resource. Well, I'll show you some code examples later on. And then, of course, there's the bottom part of it, which says, okay, I need to go out into something else, into a database, into another service, into an external party, into whatever storage capacity is out there on the cloud, right? You can go to different buckets, whatever you need, right? We have our images in buckets, so our document service reads from those buckets, etc. And that's the thing. So actually, we've been doing this pattern for a long time. This is a code base, a .NET code base, actually, that I found of one of my teams that has this particular layering as well, right? And if I go through history of my code, this is a repo class. So repo is the pattern that we use to get stuff from. This is one in C#. This is one in Java. It's, by the way, a very functional way of writing Java. We really like to write monads. There's probably a talk about monads somewhere on the conference. Go there because it's an important technique. Also, here's one in Python. It looks really different. It's the same thing. And here's one from my current team. This is what? It's the shop repo. So this is in the shop service, getting our shops. Typical TypeScript code. It's basically how we roll. We also, by the way, name things very short. So we need to do this because we have more repositories than we have people, right? We have about 120 of these small services, small apps, workers. They all have the same structure because, well, we are a small team, which means we need to rely on a single stack. You see more and more companies do that. We move to a TypeScript stack. We put everything in TypeScript. Basically, our backend code is in TypeScript and Node. Our front-end code is in React and TypeScript. Our mobile app is going to be React Native in TypeScript. We're still working on it. So everything, even our infrastructure, is coded in TypeScript. It's nice to have that if you are a small team, right? We have 13 people. We cannot afford to understand multiple stacks. We just can't do that. So we move to a single stack. And you see more companies do that. By the way, if you want to read up on this particular architecture, it's in the repo of, this is Agile Easy, which is the open source framework we're building. There's a short explanation of this, actually. So I'm not saying use this particular architecture, but do something like this, please, because it will help you move away from not being able to read other people's code. So the last part, basically, is talking a little bit about cycles. We have to talk about cycles, right? Because as I saw over time, is that Scrum doesn't cut it, right? For us developers, Scrum is not a requirement. It's starting to get in the way, basically, of what we do. Because of the technology changes that has appeared over the last 20 years, we can move much faster than this, right? We can go to a situation where we deliver value continuously. And this is what Jess Humble says, the author of the Continuous Delivery book. He said, if it hurts, do it more frequently and bring the pain forward. He is talking about software, right? Just to make no mistakes here. It's not something, it's software, right? So this is the whole point. Because, well, if you have this cycle of we deliver our monolithic application every 3 months in a new version, or every half year, or every year, what happens is there's a lot of changes in there. You need to test all of them, and you need to test the integration on all of them. And that means that over time, there will be more and more of this integration, which means you'll slow down. If you have 3 months, you go to 4 months, and then you go to half a year, and you go to a year, and then you stop deploying to production at all, right? I've seen companies actually been there. It's terrible. It's always, again, it's the dependencies that kill you, right? It's the dependencies that kill you. This is actually a chart from one of my clients in about 15 years ago. This is their systems landscape. It's not classes. These are systems, right? There are 2 SAP systems in there. They're huge, basically. So the CRM system has 142,000 tables in there. That's why SAP consultants are so expensive, by the way. So everything they push through, they needed to go through all of these dependencies and figure out whether they were still working. They could not move to production anymore at some point in time. So what would help is if you realize this. Jason says, missing the bus is not a big deal if you know that there'll be a next bus in 5 minutes. Figure that out, right? I came from the airport yesterday. Last time we got here, we decided to walk from the airport to the city, which is really nice. It's really nice, like you pass the zoo and all this stuff, and you end up in the city. This time we took the train. And we were like, we're not going to hurry, because if we miss this particular train, there'll be another one in by 10 minutes, right? It's okay. If the next one doesn't leave until tomorrow, well, you're in a different ballgame, right? That's it. So you need to make sure that you can go here, that the next train will leave in 5 minutes. So that means if you start moving into small changes, small components, and deliver them all the time, independently of the rest, and that's what this split up that I just told you about makes it possible, you can actually go here. And you can actually say, all these changes, we're going to push them individually. And you can go to something called continuous deployment, which is the next step from continuous delivery. Continuous delivery means you push them all the way through the pipeline, and then you still make a final decision. Somebody looks at it, and then you press a button, basically. If you don't do that, you just push out to production all the time. That is called continuous deployment. Should Should you go here? Well, it depends on your situation. But I would make steps to actually go towards this direction, right? It's a dot on the horizon. I'm not sure if it's, well, you can actually see it well. This is our GitLab pipeline from one of our services. I took the screenshot last week. If I would have the time, I could open up everything, but that's for longer versions of this talk. So it has all these steps, right? We built so I pull the repo, I make some changes, I run all my unit tests, and if they're good, I pull the repo again, by the way, but I'll get to that to point. Then I push, and if I push, it goes here, right? It builds the code, it runs the linter, the formatting on it. We run all the unit tests in the pipeline again, right? Then Sonar gets a hit at it. I'll show you what Sonar is if you don't know that too. We publish it. It goes into a Docker container. I don't care. It's automated, right? And then we deploy that thing to our dev environment, which is also automated, by the way. We run the API tests on it, which are in my code base, in my repo. They run. If they run, we push it to acceptance. There we can either choose to actually have people look at it, which we sometimes do for bigger features. Other than that, we run the load test and we push it to production. I could have started this talk by pushing something from a pipeline, and it would have been in production if everything goes right already, right? That means that every one of our services and our apps have their own pipeline. They're templated, by the way, so it's infrastructure that is templated. So if we want to add a step to the pipelines, we add it in a template, and the next time the pipeline runs, it picks up the template again, and it figures out a way to run that thing. So we can add stuff to the pipelines whenever we want. We do that per service, we do that for our apps as well, right? So and that actually leads us to a situation where we do this all the time, right? We make small changes, so we break them down into small features, and we run them to the pipeline individually, the pipeline of that particular service or app or worker or whatever we have. And at this point in time, this is also a screenshot I took, I think, last week. There's no date on there, right? No. It took 18 minutes to get to the pipeline. I find that long already, but it's the pipeline, so I'm not going to wait for it. It's just there, it rolls out. If it doesn't, the pipeline breaks somewhere, I need to fix it immediately, right? So we have very short feedback cycles on that, and having short feedback cycles is what you aim for. In order to do this, you need to automate everything, right? That means you need to start building the quality into the product. And these are very wise words by Edwards Deming. And this is something to really think about. He says, eliminate the need for massive inspection by building quality into the product in the first place. That is a deep statement. He made it a long time ago. He's a very smart man, by the way. And you need to think about this. That means, so who of you does, do you do pull requests? Well, I suppose most of you do, right? You have pull requests, people look at it, it's too late. Like, what? We always do this. Yes, but that doesn't mean it's right. It's the same when people wrote a horse and carriage. It was really fine until somebody invented the car. And I'm like, yeah, but we like riding horse and carriage. Sure, it's good for tourists. And we did it on the big square here, of course, but it's not what you can do. You can do much more, right, than that. I'll show you. So, infrastructure as code. I have 3 more minutes, and I'll probably be able to round it up on time. You need to move into everything as code. It just needs to be there. If our infrastructure falls down, if the stuff needs to scale, if our database breaks down, they will come back automatically. There's no attention to this whatsoever. We built these scripts, they're okay, we sometimes change them a bit or add a bit to it, but that's basically it, right? That's all you need to have. Don't do this manually anymore, because it slows you down and the feedback cycle gets longer. Same goes for testing. Instead of saying, oh, I have some unit tests, I have some integration tests, and then lots of people test, they look at it, and they click the buttons and everything, you need to move away from this in order to go this direction. In order to go faster, get shorter feedback, move into small cycles. And that means do this really rigorously. Have unit tests for most or all of your code, right? Look at high percentage of code coverage. We do that all the time. So, for instance, we have testing everywhere in the pipeline. It's there. We run all the tests before we check in too. We write unit tests. It's a discipline. You need to get used to it. It's boring at first, but you know what? Writing unit tests is also just writing code. And by the way, it's also code, so you also need to maintain it. You also need to refactor your unit test from time to time, because they'll get outdated, right? You don't want that. So do this in your pipeline all the time. We use Sonar. We have thresholds on code coverage, not because we're rigorous about it, but because we want to make sure that our code is tested. We just require the discipline. So on existing code, it's 80% is the threshold. Also on new code, it's also 80%. Because if you have code If you have a fairly large code base, most of our code bases are not larger than like 1,000 lines of code. That's basically it. However, if it has 95% and you add 3 lines to it, it still has 95%, or maybe 94.9. So it still passes, but your new code doesn't have any tests. So if you continue to do that, it'll break at some point in time, and then you have to pick up everything. So you need to keep on track with this. You need to also have these thresholds on your new code as well. But if you do this, the good thing is it allows you to code with confidence, which is a really nice place to be, right? If I run my unit test, I'm fairly certain that I can push to production, even if it is changes to our website, our public-facing websites, which 2.5 million people use, we push to it all the time. And that is a luxury we created ourselves. By the way, the reason this developer is praying, of course, because he's using light mode, right? You don't do that. It should be illegal. Anyway, so some few last remarks is that if you go into this direction and you build the quality into the product, that means that inspection later on, basically being pull requests, being code reviews, they're too late. You could, again, it's what we did, you could change that into saying, what if we don't do that? What if we build the code together instead of somebody writing the code and somebody else checking it later? Because that time frame is lost, basically, because you have to go back. Sometimes it takes a couple of days before they do this, and you have to go back into your code and like, what did they mean by this? Oh, wait, I was working on this last week. What did it do already, right? That attention loss is very expensive. So instead, you could move to trunk-based development. Is anybody doing trunk-based development? Good. Well, in the early adopters, I would say, probably still. But what trunk-based development does, it means you don't branch. Like, what? I don't branch. We cannot do that. Well, we can, because we have 120 code bases with 13 people, which means the risk of somebody else being in the same code base is not that big. And even if they would, what we do is, if you don't have branches, what is the discipline you require? It means what you will do is you will check in much faster than if you would have a branch, right? Branches always become longer, right? It's like Hofstadter's law. Everything always takes longer, even when you take into account Hofstadter's law. So this is the problem with branching. You're used to, it's in a branch, so I'm safe, which means I can keep it for a month. And then I have to merge it back. And when I merge it back, that is very, very expensive. So lose the branches. That means you get the discipline to do this. I'm almost there. So, and then you can focus on a single problem every day. I'll show you what my team does at this point in time. And then we're through, actually. We realized, this is French, but the quote says, perfection is reached not when there's nothing more to add, but when there's nothing left to remove. Think about that for a bit, right? Do this. So we removed everything that got in our way. We don't have Scrum. We don't have Kanban either. It has no name, basically. It's how we roll. We don't have sprints. Sprints are just 2 weeks. What is 2 weeks if we deploy to production 80 times per day or 50? We don't do retros. Retros are boring, right? We just lost them, basically. We don't have a Scrum Master. We don't have PO. Everybody's their own PO on the piece of code that they're working on. We don't have stories. We actually do not even have documentation. We don't estimate. We're starting to do less stand-ups. If we're all in the office, like in this picture, we don't do a stand-up because we're working together the whole day, and we do that all the time, basically. So we don't do pull requests either. We don't blame people. People are people, right? We all make mistakes. That is a very nice point to be at. This is maybe some utopia point in the horizon for some people. We actually do this, and look at them smiling. No, that's just Eugene in the middle. He's always smiling, actually. They actually put a wall up behind us because he's always laughing so loud that our finance department couldn't do work anymore. Anyway, to wrap it up really briefly, this is the point. Yes, this microarchitectural thing will work if you use it to solve the right problems. Not everybody has scalability issues. Most companies do have tech problems and do want to move on faster. You can only do that when you do continuous renovation. You can only take one step at a time to get to this particular point. Meaning, lose products. Do not do projects, right? Projects are too big. Move to deploying features and do the less relevant part of your project later, probably, maybe never. Oh, I'm a little bit behind on the slide. So use shorter cycles. Go to continuous whatever you do, right? Do it with smaller teams. Make the teams get as much autonomy as needed. That's the part I did skip for this talk, and move to smaller components. And whether that is a modular monolith, or whether you actually have microservices in different repos, that's fine. the conclusion for us over the years has been less is always more, right? Keep that in mind. We solve a single problem every day. That's all we do with the whole team. By the way, in this industry, you can never, ever stop learning. So it's very good that you are here all for the conference, which is a great conference, by the way. I love Devoxx Poland. And never forget to have fun, because we are in the best industry out there in the world. One more thing, if everything else fails, if you cannot do anything anymore, you just remove your Node modules and you do an npm install, right? Thank you for indulging me. I hope you enjoyed the rest of the conference.